Hello, our topic is binomial random variables. A binomial random variable is the count x of successes in a binomial setting. A binomial setting arises when we perform several independent trials of the same chance process and record the number of times that a particular outcome occurs. For a binomial setting, we have to make sure that 4 conditions are met. Yeah, great. For the conditions, we can use the acronym BINS. B stands for binary. Binary means that the possible outcomes of each trial can be classified as success or failure. I stands for independent. Independent means that the trials must be independent from one another, so knowing the result of one trial will not affect the result of another trial. N stands for number. Number means that the number of trials N of the chance process must be fixed. S stands for success. Success means that there is the same probability P of success on each trial. By the way, in a binomial setting, if we want to determine the mean and standard deviation, these are the equations. The number of trials N times the probability P is the mean. For the standard deviation, it is equal to the square root of the number of trials N times the probability P times 1 minus the probability P.
Now that we know what a binomial random variable is, let's try a problem. The problem reads, a toy company claims that there's a 0.15 probability that a customer buying one of its new toys will win a complimentary gift card. This outcome is independent from purchase to purchase. Is it likely that the next 11 people in line to purchase the toy yield 6 wins or complimentary gift cards? Justify your answer. So first we would check the conditions using BINS. So B stands for binary. Are the outcomes either success or failure? So if you go back to the problem, that condition is met because it says a customer will either win a complimentary gift card or not. So the B condition is met. I stands for independent, and in the problem it says this outcome is independent from purchase to purchase, so that condition is met as well. N stands for a fixed number of trials, and it says next 11 people in line, so the number of trials is fixed as 11. And success means that the probability of success is the same at each trial, and that is also met because it says that there's a 0.15 probability that a customer buying a toy will win a gift card. So all the conditions are met. Now we can use our calculator to
So this is a
solve this
TI-84.
problem. So you would press second, bars, and select binomial PDF. And as we said earlier, the number of trials is 11. The probability of success is 0.15. And the X value is the number of successes that you're looking for. And the problem reads that how likely it is that the next 11 people to purchase the toy yields 6 wins. So the X value would be 6. And then you press paste. And you get your answer of 0.00233, blah blah. So on the AP test, however, you couldn't just write down your answer because you would get little or no credit. For the AP test, in order to gain full credit, you should define all your variables. So write down binomial PDF, and then trials equals 11, probability equals 0.15, and successes equals 6. And then you get your answer of 0.00233. Here are a couple tips for the AP test. 1. Use calculator speak to save time. If you really don't want to save time, you can use the whole formula, which takes way longer. This is the formula, in which K equals successes out of N total observations, N equals the number of observations, and P is the probability of a success. When using calculator speak, however, don't forget to show work, as if you don't show work, you won't get points. Another tip is don't forget to check the conditions. As we said earlier in the video, the conditions can be remembered by using the acronym BINS. Don't forget to check these. A common mistake that students make is getting confused between binomial PDF versus binomial CDF. You may have noticed that your calculator has both of these functions. Binomial PDF computes exactly K successes, while binomial CDF computes K or less successes. Make sure to read the problem carefully and understand exactly what it's asking for. And of course, another common mistake is forgetting to show work. Don't forget to show work.